All right, so in this video, we're going to look at an example of a word problem using our matrices to help us set up a system and solve. So we have example 4, which says a convenience store sells 23 sodas one summer afternoon in 12, 16, and 20-ounce cups, being small, medium, and large sizes, respectively. The total volume of soda was 376 ounces. Suppose the prices for a small, medium, and large soda are $1, $1.25, and $1.40 respectively, and that the total sales was $28.45. How many of each size did the store sell? So ultimately, we want to know how many of each size did the store sell. So we want to think about the fact that we have a lot of information here. So we're going to need to go through that information and pick apart the pieces that are going to be necessary to help us set up our system correctly, because that's really one of the biggest pieces, is making sure we generate a system of equations that's accurate so that we can then use that and set it up in our matrix, use those row operations we talked about last class to help us solve that system to figure out how many of each type of soda they sold. So we have 3 different soda sizes that are being sold. So we are going to assign a variable for each one of them. So we're going to let X be a small. We're going to let Y represent a medium. And we're going to let Z represent a large. So we've established that we have 3 different sizes. If we go back through the word problem and kind of start analyzing the different pieces of information we have, one of the first things that we're told is that this convenience store sold 23 sodas one summer afternoon. So we know that there's some combination of these different sizes that were sold, but they sold some of each size. So that gives us our first equation. X plus Y plus Z is equal to 23. Okay, if we go back, they sold 23 sodas. We're told how many ounces are in each cup, and we're told that the number of ounces corresponds to the various sizes. So we have 12, 16, and 20 ounce cups. They also give us the total volume of the soda. So we notice the total volume of the soda is in ounces, just like the different size cups are. So we're going to use those pieces of information and put those together to generate our second equation. So we have 12, 16, and 20 ounce cups. And the total volume is 376. So they tell us that 12 ounces is our small, 16 ounces is our medium, and 20 ounces is our large. So when we set this up, we're going to set that up as 12x plus 16y plus 20z equals 376. And so looking at the problem again, we want to look at what information we have remaining. So we've identified how many sodas were sold. We've identified the different sizes and the total volume of soda. The last thing we have is looking at the price. So they tell us the price for each different size. The price for a small is $1, the price for a medium is $1.25, and the price for a large is $1.40. And they also tell us the total number of sales is $28.45. So we use that to give us our third and final equation for this system. So we have 1x plus 125y plus 140z equals 28.45. And so we said when we have a system that we want to put into a matrix, one of the first things we have to do is make sure that our system is set up in that proper order, where our constant is on one side, our variables are all on the other side of the equal sign, and they're all in that same order, in this case, X, Y, Z. So we've set up our system to be in that proper order. So we go ahead and put these in our augmented matrix. So we have 1x plus 1y plus 1z equals 23. Our second equation is 12x plus 16y plus 20z equals 376. And our last equation is 1x plus 1.25y plus 1.40z equals 28.45. And we said we want to make sure, just like with the original equations, that we have the constant separated from the coefficients on the variables. So we do that with that vertical line in that augmented matrix. And so from here, now we start looking at row reducing. We start looking at that lead entry. So if we go through this and we think about in that first row, in that top left entry, we have that value of 1. So that is our lead entry in the first row. We said once we've established that the lead entry is a 1, we want to generate zeros above and below that entry. So in this case, there are only entries below it, so we need to get both of those entries to become zeros. So using our row operations, we have those 3 different operations we can choose from. And in this case, it's not going to benefit us to switch the position of any 2 rows. It's not going to benefit us to just simply multiply an entire row by a non-zero value. We're going to have to use that operation that requires us to take that first row, the row with that lead entry, multiply it by some value, and then add it to a different row so that the entry in that different row becomes 0. So if we use that, we can look at actually getting all of those zeros in one step if we choose to do so. So if we think about that second row where the 12 is, and what we would need to do to turn that into a 0, we're going to have to take that first row and multiply it by a negative 12. So we're going to take negative 12 times row 1, add it to that second row, and then it's going to replace our second row. So those values will become the new values in that second row. So we're not changing anything in the first row because that lead entry is already a 1 and we want it to stay a 1. So our top row is still 1, 1, 1, and 23. Our second row is going to change because we said that 12 needs to become a 0. So when we do our calculations, negative 12 times the 1 that's in that top row plus 12 gives us 0. Negative 12 times that 1 plus 16 is going to give us 4. Negative 12 times 1 plus 20 is going to give us 8. And then we've got negative 12 times 23, and we add that to 376 to get a value of 100. And we said you can do these row operations one row at a time like we did earlier in class. Or in a case like this, if you want to just get all of those zeros in a single step, you can go ahead and perform those operations together. So we're going to look at also getting that 0 in that very bottom row. And we notice in this case that leading entry of 1 in that top row and the value for the entry in the bottom row are both positive 1. So all we have to do is take that very top row and multiply it by negative 1. So we're multiplying row 1 by a negative 1. We're adding it to that third row because we need there to be a 0 in that very bottom row. And that's going to become our new row 3. So when we do that, just multiplying that entire top row by a negative 1, So 1 minus 1 gives us 0. Then we have a negative 1 plus 1.25 will leave us with 0.25. Negative 1 plus 1.40 leaves us with 0.40. And that will give us negative 1 times 23 would be a negative 23 plus 28.45 will leave us with 5.45. Okay, so we've established that the lead entry is that 1 in our top row. We've got all of our zeros below it. So now we look at going down a row and to the right to find our next lead entry. So currently that lead entry in that second row is 4. However, we want to remember that when we're row reducing and we're trying to get down to our final solution, if we have an entry that is not a lead entry, that's not a 1, we need to use those row operations to turn that value into a 1. So in this case, we're going to use that operation that allows us to just multiply that entire row by a non-zero value. So we're going to multiply the entire second row by 1/4. So we're going to have 1/4 times our second row is going to become our new second row. So we're going to replace just the second row in this next operation. So just for space and because of formatting, we're going to go down to the next page to finish this. So that means our new matrix, after we multiply by that value of 1/4, we said is only changing that second row. So our first row is still going to be the values of 1, 1, 1, and 23. Our second row is going to become 0, 1, 2, and 25. And then the bottom row is not changing from the previous matrix. It's still going to be 0, 0.25, 0.40, and 5.45. Okay. So we have the lead entry of 1 from the top row. In our second row, we have that lead entry of 1. So now this is when we need to get those zeros above and below. So similar to what we did earlier, we're going to use that row operation where we multiply and then add. So in this case, our goal is to change the values in the top row and the bottom row, but that middle row is not changing. So again, we're in a situation where our lead entry in the middle row and in this case, the entry above it are the same value. So all we have to do is multiply that second row by a -1, add it to the first row, and then that's going to replace the first row. So our first row is going to change this time. That 1 will stay. -1 plus 1 will give us 0. -2 plus 1 will give us a -1. And -25 plus 23 will give us a -2. Our second row is not going to change. 0, 1, 2, and 25. And then our bottom row also needs to change so that we can get rid of that 0.25. So we're going to have to multiply our second row by a -0.25. Add it to our third row, and that will give our new third row. So 0 times anything is still 0, so this entry is going to stay a 0. -0.25 plus +0.25 will give us a 0. -0.25 times 2 plus 0.40 will give us a -0.1. and negative 0.25 times 25 plus 5.45 will give us a negative 0.8. So we have our lead entry from the first row, our lead entry in that second row with the zeros above and below. So now we just need our lead entry in that very bottom row. So remember, we go down a row and we go to the right. So it's currently this value of negative 0.1. And so with it being a decimal, we do want to still figure out what we would have to multiply by to make it into a positive 1. In this case, we're going to multiply it by a value of negative 10. So we're just multiplying that bottom row by negative 10. And it's going to replace that bottom row. So our first and second rows will not change from that previous matrix we just did. So we have 1, 0, negative 1, negative 2. And we have 0, 1, 2, 25. This bottom row, the first two entries will be zeros. And then we're going to multiply by negative 10. So multiplying by negative 10 is going to take that decimal and just move it to the right one position. So that will turn this into, so let's do this. Turn that into a positive 1. And then when we do negative 0.8 times negative 10, that's going to be a positive 8. So now we have our lead entry from row 1, from our middle row, and from that bottom row. So now we just need to look at getting those zeros above. So one final time using that operation that we've been using and been practicing with, we're going to change the values in row 1 and row 2, but that bottom row will not change. So comparing that entry in row 1, it's a negative 1, and we already have a positive 1 in the bottom row. So all we need to do is take row 3, add it to row 1, and then that will give us our new row 1. So we said row 1 will change. That first entry is not changing. The second entry is not changing, but this third entry is going to become a 0. And then if we do 8 minus 2, that will give us 6. We also need to change what's in the second row because we need that 2 to become a 0. So we're going to take that positive 1, in the bottom row and multiply it by a negative 2. So negative 2 times row 3 plus that second row will give us the new values for the second row. So we're going to have 0, 1. This will become 0. And then if we do negative 2 times 8, negative 16, plus 25 is going to give us a value of 9. And then we said that bottom row was not changing in this step. 0, 0, 1, 8. And so if we take these equations out of the matrix, just to kind of look at them and interpret what we have at this point, we would have 1x plus 0y plus 0z equals 6. We would have 0x plus 1y plus 0z equals 9. And we would have 0x plus 0y plus 1z equals 8. So this tells us right here, x equals 6, y equals 9, z equals 8. So we've identified what x, y, and z equal. We just need to remember what those variables represented. What did we assign to each of those variables? So if we remember, this problem was looking at a convenience store selling different sizes of soda. So we said, if we go back up and check, X, Y, and Z were the different sizes for those sodas that they were selling. So we said X was our small size, Y was our medium size, and Z was our large size. So we would say that the store sold 6 small, 9 medium, and 8 large sodas. So that would be our final answer for this word problem.